So we're going to take a look at solving rational word problems with our rational expressions, rational function unit. To solve problems involving work, we're going to look at this formula. Part of the work completed equals the rate of work times the time worked. Now, please notice that you do have guided notes for this, and I would recommend that you use it. Alrighty, example, if it takes 5 hours to paint a room, what part of work is completed after 3 hours? If one room can be painted in 5 hours, then the rate of work is 1/5 the rooms per hour. The time worked is 3 hours, okay? So we know that part of the work completed is equal to the rate of work, which in this case is 1/5 rooms per hour times the time worked of 3 hours. So notice we just multiply 1/5 times 3 is equal to 3/5. So far, all of this is just fractions, right? So 3/5 of the work is completed after 3 hours. Let's take a look at this word problem now. If a painter can paint a room in 4 hours and her assistant can paint the room in 6 hours, how many hours will it take them to paint the room working together? Okay. I always recommend that you set up a chart, a table. Okay. Notice we have the rate of work, we have the time worked, we have part of the work completed, and we have the painter and the assistant. So the painter can do 1/4 of the work in 1 hour. We don't know the time worked, that's what we're trying to find. So the part of the work completed is T/4, right? Because it's going to be the time over the rate of work. The assistant needs 6 hours to paint the room, so the rate of work is 1/6. The time worked is T, and so it's T/6. If we add the part of the work completed by both the painter and the assistant painter, we'll get T/4 plus T/6 is equal to 1. That 1 represents the room. We can notice that our LCM is going to be 12. Okay, so we're going to multiply each fraction by 12. So I'll multiply this fraction by 12, this fraction by 12, and the 1 by 12 as well. Okay, notice that what happens is we do reduce. So 12 divided by 4 is 3. 12 divided by 6 gives us 2. Okay, then we just add the 3t and the 2t to get 5t is equal to 12. Divide by 5, so t is equal to 12/5 or 2.4. So working together, they will paint the room in 2.4 hours. To solve problems involving motion this time, we're going to use the formulas distance equals rate times time, and time is equal to distance over rate. So let's just take a look at some examples of how we would use these. If a car travels at 60 miles per hour for 3 hours, what distance has it traveled? Notice that in this case, we're going to use the first one. We're just looking for distance. So our rate is 60 miles per hour. The time is 3 hours. The distance is going to equal rate times time, which is equal to 60 times 3 for 180. So the car travels 180 miles. How long does it take an airplane to travel 1,200 miles flying at a speed of 250 miles per hour? Now we're looking for time, so we're going to look at our second equation. So the distance is equal to 1,200 miles, and the rate's equal to 250 miles per hour. Time is equal to distance over rate, so we take the 1,200 miles divided by the rate of 250, and we get 4.8 hours for the plane to make its trip. All right, let's take a look at this word problem here using the formulas that we just went through. A traveling salesman drives from home to a client's store 150 miles away. On the return trip, he drives 10 miles per hour slower, adds 1/2 hour in driving time. At what speed was the salesperson driving on the way to the client's store? Okay, we're going to let R be the rate of travel, the speed per mile. We know that the distance is 150, the rate's going to be R, And so the time, remember, is equal to the distance over the rate. Okay, and that's where we get the 150 over the R. The trip home, still 150 miles, but now it's R minus 10 because he traveled 10 miles per hour slower. So we have 150 over R minus 10. So we need to figure out, now it adds 1/2 hour in driving time. So that's where the 1/2 comes in at, okay? So we're going to have 150 R minus 10 minus the 150 over R, and that's going to be equal to your 1/2 hour, okay? Notice that our LCM is 2R, R minus 10. So we're going to multiply both sides by the LCM, okay? And when we do that, notice that this 150 is just going to really be times by the 2R. And then this one right here will be times the 2 as well, but also by the R minus 10. Okay. This side over here, the 2's are going to cancel, and so you'll just have R times R minus 10. Okay, let's take a look at this. So we're going to do some distribution of our sides, and we're going to move everything over to the other side, okay? We're going to notice that these two terms totally cancel out. So we do have a quadratic, okay? With our quadratic, notice that our factored terms here are going to be negative 60 and 50, which would add up to be, if you multiply them, they'll be 3,000, but if you add them, they'll be the negative 10. Okay, so you do need to factor. Okay, so negative 50 is going to be irrelevant, and the reason why it's going to be irrelevant is because it's negative, and we cannot have negative speed. Okay, so the salesman drove from the home to the client store at 60 miles per hour. 60 miles is the time it takes to drive 150 miles from the salesperson's home to the client's store, and that's 2.5 hours. Remember, though, he drove home slower at 10 miles, so he just drove 50 miles per hour, the 150, which gives you 3 hours. So you can see how the return trip took 1/2 hour longer. All right, let's take a look at another one that's kind of like the paint one. A sump pump can pump water out of a basement in 12 hours. If a second pump is added, the job would only take 6 2/3 hours. How long would it take the second pump to do the job alone? And again, you want to make up a table. We have our first pump, our second pump, and if they're working together. Okay, so the first pump, it said, takes 12 hours to do the entire basement. The second pump, we don't know, but when they work together, it's 6 2/3. Okay, which will change to an improper fraction of 20 over 3. The fraction of the job, the first pump is 1 over 12. The second pump's 1 over x, and then when they work together, it's going to be 1 over the 20 over 3. So we have a complex fraction there. See that? Okay, so we're going to add these together, 1 over 12 plus 1 over x, and that's going to be equal to the 1 over 20 over 3. We do need to flip our fraction, and then what is going to be our LCM? That's right. Our LCM or our LCD is going to be 60. Notice in this case, the way that it's set up is we're going to multiply 60x to all three of these. And then we're going to come through and we're going to cancel. Okay, so like 60 divided by 12, the x's here are going to cancel. 20 divides into 60 for 3, okay? 12 goes into 65, okay? So we'll get 5x plus 60, and that's going to be equal to 9x. So now all we do is have to subtract 5x from either side, so we get 60 is equal to 9x minus 5x. 60 is equal to 4x. Go ahead, divide. Our x is equal to 15. So that's 15 hours for the second sump pump, okay, all by itself. All right, we'll take a look at some more distant rate and time problems. So if you drive at a constant speed of 60 miles per hour and you travel for 2 hours, how far did you drive? So again, we're just multiplying. Notice how our time is going to cancel, leaving us with the miles, okay? So remember, D equals R times T. D over R is equal to time, and distance over time is equal to rate, okay? So a car travels 600 miles in the same time a motorcycle travels 450 miles. If the car speeds 15 miles per hour faster than the motorcycles, we have to find the speed of both vehicles. So again, I recommend you set up this nice little table here. The motorcycle, we have no idea. But we do know the car is 15 miles an hour faster than the motorcycle for rate. The time, we don't know either. The distance is 450 for the motorcycle and 600 for the car. So we're going to pick and use, because we want to find the time, okay, we need to in the same amount of time. So when they say the same time, then if we find the time, then we'll be able to find the speeds, okay? And so notice it's 450 over x. And then the second one is 600 over x plus 15, because the car is going 15 miles per hour faster. All right, so once we do that, we set this up. What's going to be our LCD for this? That's right. Our LCD is going to be x plus 15. And again, we're looking at the same time, so we get to set these equal to each other. Okay? Notice that we get to cancel the x's out here. And over on this side, we get to cancel out the x plus 15. Okay? So we'll distribute the 450 through. See that? And we wind up with the equation looking like this. Go ahead and solve it. All right, so we'll move our x's to the other side, and then 450 times 15. Notice that the x is 45. Now, what does that 45 mean? Remember, that's the motorcycle. The motorcycle speed was equal to x, so that's 45 miles an hour for the motorcycle, okay? And the car was 15 miles faster. So 45 plus 15 is 60 miles per hour. All right, let's take a look at this one. This is a boat can travel 22 miles upstream in the same amount of time it can travel 42 miles downstream. The speed of the current is 5 miles per hour. What is the speed of the boat in still water? Okay, so we have upstream, downstream. Please remember the boat speed is going to be equal to x. Now notice that the boat speed is not really in our table. Instead, we're looking at upstream and downstream because that's where all the information's at. Upstream, you're going against the current, so it's x minus 5, and downstream, you have to add the current because the current's helping you along. We don't know the time, but we know the distance was 22 miles upstream and 42 miles downstream. So again, we're going to use T is equal to D over R. So we'll have 22 over x minus 5, and then we'll have 42 over x plus 5. Okay? Alrighty. We again get to set these equal to each other because the time is the same. And what's going to be our LCD? That's right, our LCD is going to be equal to x minus 5 and x plus 5. Right? And again, notice that whatever's in the denominator, we cancel. And this keeps these problems simplified. Notice we don't have an x squared. Okay? So again, we did our cancellations, and now all we do is have to distribute. And somebody go ahead and select what answer is going to be for X. Alrighty, so our X is going to be worth 16. That's correct. Okay, and so our boat speed is 16 miles per hour. Okay, so thank you for participating, and these are the types of word problems you're going to deal with rational functions. The end.